Paddy-grown rice is one of the most important crops in the world. For more than 10,000 years, rice has fed the people of Asia. And today, rice is a major crop worldwide, grown using methods from the traditional to the very modern. Each year, farmers produce 450 million tons of rice, which serves as the staple food of over 3 billion people around the globe. And the rice-eating population is growing. By 2030, 5 billion people will depend on rice for the majority of their calories. But, like other crops, rice can be contaminated by pollution from the environment. One of these pollutants is methylmercury. Methylmercury is a severe nerve poison that most people are exposed to in foods that come from wet environments. You've probably heard of methylmercury in fish, but unfortunately, methylmercury also exists in rice. After a person eats methylmercury-contaminated food, the poison moves to their brain and nerves, causing damage. These problems are worst for babies and young children because their nerves and brains are still growing fast. For these people, even small amounts of methylmercury can permanently lower intelligence. Unfortunately, methylmercury is almost impossible to escape. This is because it is created from inorganic mercury, a pollutant that is present in almost every environment. Every year, more inorganic mercury is released from natural sources, like volcanoes and wildfires, as well as from human activities, like burning coal, cement production, and other industries. Today, one very important source of inorganic mercury is artisanal and small-scale gold mining, where mercury is used to help extract the gold from the rock. This inorganic mercury travels in the air and water and eventually ends up in the soil. Mercury in soil can't be easily cleaned up and will be in the environment for tens of thousands of years. This means that mercury is a problem that's here to stay. Only some of this inorganic mercury is converted to methylmercury. But because even small amounts of methylmercury can harm our health, and because so many people depend on rice for food, this is a serious problem. Fortunately, we can find solutions by understanding the methylmercury cycle. The methylmercury in rice grains comes from the soil, but remember that the mercury in soil is mostly the inorganic kind. So where does the methylmercury in soil actually come from? Methylmercury is created from inorganic mercury by some soil microbes. These microbes, which live in wet, oxygen-free places, absorb the inorganic mercury and convert it to methylmercury. Some, but not all, of this methylmercury is taken up by the plant roots. Over time, methylmercury moves upward into leaves and stems, and finally into the grain as it ripens. After harvest, the rice with its methylmercury ends up on our plates. It's important to remember that most rice is safe. The industrial food supply mixes rice from many farms, so an individual person eating store-bought rice probably won't be exposed to unhealthy levels of methylmercury. But in areas where there is serious mercury contamination, like near ancient mercury mines or where people are using mercury to extract gold today, the methylmercury in rice can be much higher. In these contaminated areas, if people depend on local rice for their staple food, then health problems can result, especially for babies and young children. The need to act is urgent. Because it's impossible to clean up inorganic mercury in soil, the best controls are to stop methylmercury from being formed in the first place, or from moving up into the rice grains. Fortunately, there are several simple, existing agricultural strategies that may help farmers do this. The first step is to estimate whether or not there is a problem for local people by measuring the amount of methylmercury in rice grain and accounting for how much rice people eat. Resources to do this are outlined at our website. There are thousands of kinds of rice, and not all of them move the same amount of methylmercury from the soil to the grain. Low-accumulating rice varieties can have up to 75% less methylmercury than other cultivars. Growing these varieties in places with mercury problems could be very effective, but low methylmercury varieties have only been identified for some areas of China. More research is needed to find low methylmercury rice for other locations. Another approach is to reduce the creation of methylmercury in the soil, using an existing popular agricultural technique called alternate wetting and drying. This method involves allowing the paddy to dry out and then flooding it again. Alternate wetting and drying works by changing which microbes live in the soil, as well as reducing the activity of mercury methylators. Microbes that create methylmercury don't grow well when the soil is dry, so drying out the field reduces their activity. In this way, less methylmercury is formed. Rice grown in alternate wetting and drying fields has up to 60% less methylmercury than rice grown in continuously flooded fields. Simple agricultural trials can predict how much the reduction might be in your area. It is also important to understand how alternate wetting and drying changes the concentration of other contaminants and nutrients to ensure that it produces safe, healthy, and high-yield rice crops. And farmers also need support to try new techniques. The International Rice Research Institute can advise on how to get started with alternate wetting and drying cultivation. Although these approaches are promising, they are not enough to eliminate the threat of methylmercury in rice. Scientists are continuing to study mercury methylation and uptake into rice to develop more solutions in the future. Methylmercury contamination of rice is a global problem, but it is one that we can overcome and keep the rice supply safe for a growing world.